In my last video, I shared how I recreated the 3D pipes screensaver in the browser using three.js. It was a very fun project, but there was one thing that kept bugging me, and it was the poor performance optimization. And when I say poor, I mean no optimization at all. I used a very naive approach for rendering where I would render every mesh from the scratch. For a few hundred meshes, this is probably fine because the GPUs are very fast. But as the number of meshes increases, the performance starts to take a severe hit. For example, this is how the project currently runs at maxed out parameters. So my goal is to optimize this project so it can run very smoothly even if all the parameters are set to their highest values. So right now the core part of the issue is the fact that every piece of pipe that you see on the screen receives its own geometry and a mesh. For a few segments of pipes, this is not a problem, but as the number of segments increases, the performance starts to take a hit. Because every time I want to draw a mesh, I first need to create a geometry object which stores the data about the structure of the mesh. For example, a sphere or a box or a cylinder. And then I need to create a material object which basically decides what the texture of the mesh should look like. This geometry object and the material object get packed into a mesh object, and all of this data gets sent over to the GPU in a process which is technically known as a draw call. Then the GPU allocates the video memory for this mesh and draws it on the screen. This is a vast oversimplification of the entire rendering process that usually happens 60 to 30 times a second. So if I do some simple math, let's say I want to draw 50 pipes and each of them have a length of 1000, then I end up with 50,000 meshes. And this isn't even accounting for the fact that when the pipes take turn, I draw the joint which takes 3 separate meshes. So on each frame there are roughly 50,000 draw calls being made, which is quite excessive for a simple project like this. So how do I optimize this? If you take a look at the scene, then it's a very simple scene that only uses 2 types of meshes. A cylinder mesh for the pipe segments and a sphere mesh for the joints. This means that we don't actually have to create a new mesh object every time we need to draw a piece of pipe. We can create these 2 types of meshes only once at the start and then ask the GPU to cache them. And whenever we need to draw any segment of the pipe, we can tell the GPU to draw from the cached version of the mesh. And now we don't need to make thousands of draw calls every frame because the GPU already has the data that it needs to draw a mesh in its memory. This is the whole idea behind mesh instancing. You basically ask your GPU to remember a mesh, and then you can create hundreds or even thousands of copies of the said mesh at very little cost on performance. So let's implement this. At first, this may seem like a complicated thing to implement, but this is not a unique problem. And as usual, three.js already has a great abstraction built for this specific problem called instance mesh. So I'm just going to use that. I start off by throwing away the code that created a new mesh for each pipe segment, and I bring in the instance mesh from three.js. One of the requirements of the instance mesh is that you need to provide it the number of copies that you want upfront. So I wrote a for loop that calculated the number of segments and the number of joints that are required for each scene. After that, I initialized 2 instance meshes, one for the segments and one for the joints. Then all I had to do was replace the parts where I create new meshes with the instance meshes. After this, three.js will take care of all the heavy lifting. And believe it or not, this is all the changes it took to make the project run extremely smoothly even at the highest parameters. Here is an example of this project running with all the parameters maxed out. And that's all for this video, just a neat optimization trick that I learned and wanted to share. If you're interested in checking out the full project, the links are in the description. And as always, thanks a ton for watching.